Atomic structure and the source of charge. To understand where this electric charge comes from, we have to turn to the basic structure of matter. All matter is made up of atoms, which are made up of protons, neutrons, and electrons. Each atom contains a central nucleus that is composed of protons and neutrons, and you can call protons and neutrons nucleons. That's kind of a general term for both of them. Electrons move around the nucleus in the empty space of the atom. Electrons are fundamental particles. They have no underlying structure. They are points. Protons and neutrons are not fundamental particles. That means they're made up of something else. And what they're made up of are quarks. Quarks are fundamental particles. We'll start by talking about the electron because chronologically that was the first of the atomic particles to be found. J.J. Thomson found the electron. He found a particle that had a very low mass for its charge. In fact, its mass per charge ratio was 1,800 times less than the previous lowest amount measured for a particle. Actually, before his work, physicists were speculating that the hydrogen atom was the smallest fundamental particle. This led Thomson to propose that this negatively charged particle was new, and he called them corpuscles. The name electron was then taken from George Johnstone Stoney's work in 1874, and again proposed by George F. Fitzgerald, and the name stuck. So corpuscles was out, which actually was a term Newton used to describe light particles, and electron was in. Furthermore, since the electron was so much lighter than the hydrogen atom, it was concluded that it must actually be a part of the atom. A little more history here. The electron was discovered by J.J. Thomson, that's this gentleman over here, in 1897. And then, about a decade later, Robert Millikan and his graduate student, Harvey Fletcher, established the value of the charge on an electron. And that value is typically labeled as E. E is the charge on an electron. Millikan and Fletcher's work and subsequent experiments have established the value of E as 1.602 times 10 to the minus 19th coulombs. Obviously, there are more decimal places after this depending on how precise the measurements were carried out. It has also been demonstrated that this is the smallest value of charge possible, with the exception of quarks, which will be covered shortly. But it's the smallest value of charge you can see. You can't actually find the charge on the quarks directly. All larger charges have to be an integral. An integral multiple means you have to take this number and multiply it by 2, 3, 4, 1 billion, 7 billion, whatever. You cannot multiply this by 2.5 and get a charge that exists. Because small amounts of charge can generate large amounts of force, we often measure charge in millicoulombs, which is 10 to the minus 3 coulombs, just like a millimeter is 10 to the minus 3 meters. Microcoulombs, 10 to the minus 6. Nanocoulombs, 10 to the minus 9th. You'll probably get familiar with these the more problems you do. Many more experiments and research show that the electron has a mass of 9.1 times 10 to the minus 31 kilograms. Millikan and Fletcher found the charge on the electron. Thomson had the charge to mass ratio, so basically by putting those two together you come up with the mass. So here's the charge. For this course, we're going to cut off some of the decimals and just use 1.6 times 10 to the minus 19th coulombs. And here's our mass of the electron. Do you have to memorize these? No. This one you'll probably learn very quickly. This one you don't always remember, but we don't want you memorizing constants. Those should always be given to you. So when finding the charge on an electron, it was discovered that the charge on any object was an integral multiple of the electron charge, just like we said on the previous slide. But this is an important point, so we're going to say it twice. So you can have a charge of 3.2 times 10 to the minus 19th coulombs on an object. That would mean you have 2 electrons. But you can't have a charge of 3.0 times 10 to the minus 19th. That would mean you'd have to have like 1.8 electrons. Can't break an electron up. It's a fundamental particle. So again, the charge on any object is always an integral, 1, 2, etc., all the way up to here, 1,000,056, and then more numbers past that, multiple of the fundamental charge of an electron.